So this video is on our Chapter 8 classwork review for quiz number 1. We're having a quiz on Friday over graphing exponential graphs. I just want to review it with us. It's going to be sketching them like we are going to be doing on this page here. Okay. These ones we're going to be graphing a little more accurately because they're giving us an XY axis just so we understand how to graph these things. So in this situation, when we are doing these graphs, you want to pay attention to the equation that they're giving you. So they might give you an equation in the form y equal b to the power x. Or they might give you an equation where you have y equal a times b to the power x. Now, both situations are going to have an asymptote on the x-axis at y equals 0. Both of them are where we're timesing by our b. That's what we're multiplying by over and over and over again. Your b is going to determine if it is going to be greater than, increasing or decreasing. Now, for all of the ones that are b raised to the power x, if I was to put b to the 0 in, which would be to find my y-intercept, I would get 1. So all of our y-intercepts, when I have a base to a power only, is going to be 1. Now, in the second graph, when I put in 0 for our b, a times b to the 0, b to the 0 is a 1. So I'm going to get a times 1, which is a. So I'm always going to get my y-intercept is our a. So when we are graphing these, in this first graph, okay, the first thing I'm going to do is I'm going to draw in my asymptote. I'm going to have an asymptote right here on the x-axis. I'm going to put them in both of them because both of them are going to have the same one. And that equation is going to be y equals 0. Y equals 0. Now, on the first graph, again, if I put in 0, which would be to find my y-intercept, 0.1 to the power 0 is 1. So my first point is going to be at 1. Now, what's going to be happening in this situation is I'm going to be timesing by 0.1 and timesing by 0.1 and timesing by 0.1. So if I'm starting up here at a height of 1 and I times 1 by 0.1, I'm going to be decreasing. I'm going to be down here at, let's say, 0.1. I'm just going to approximate it, okay? Really close to the x-axis. And then I'm going to get smaller and smaller and smaller and smaller. Now, going backwards, what's going to be happening if I am timesing by 0.1, 0.1 is really 1/10. So 0.1, let me just write this out here. 0.1 is really equal to 1/10. So when I'm going backwards, I'm really multiplying by the reciprocal. So I'm really multiplying by 10. So this is going to be going up to 10. I can't get up that high on this graph, okay, but it's going to be up high. And that's going to be my graph. On the second one, I have 2 to the power x. So on this one, again, if I do 2 to the power 0, I get 1. So this has a y-intercept of 1. And then what's happening is I'm timesing by 2 and timesing by 2 and timesing by 2. So if this one here has a height of 1, I'm going to times that by 2. So I'm going to be 2 high. I'm going to times that by 2. So I'm going to be 4 high. I'm going to times that by 2. I'm going to be 8 high and so forth. Now going backwards, this is 4 and 2 and 1. So every time it's a half of what it was. So this is going to be a half and a fourth, and so forth. And in this situation, I get an increasing graph. Okay. Now, for this, it says, when the b is between 0 and 1, what happens to the graph? So that's this first one up here, okay? And what happens to the graph when your b is between 0 and 1? So I'm just going to write 0 less than b less than 1. What's going to happen is we're going to have a decreasing graph. Decreasing graph. This one here, my b was greater than 1. It's a 2. So when my b is greater than 1, I'm going to have an increasing graph. Okay. Now, on the ones below, they're like this one up here, a times b to the power x. So you'll notice this one was 0.1 to the power x. This one down here is 3 times 0.1 to the power x. So now I have a number in front. This one up here was 2 to the power x. Now we put a number in front of it, 3 times 2 to the power x. Now the difference is going to be the following. This one here is still going to be decreasing because I'm timesing by 0.1, which is making it smaller and smaller and smaller. This one over here is still going to be increasing because I'm timesing it by 2, timesing it by 2, timesing it by 2. But I'm not going to be starting at 1 like I did on these ones. Because what's going to be happening here is when I'm doing these graphs, and for example, I put in 0 for my x to find my y-intercept, I'm going to get 3 times 1 or 3. That's going to be my y-intercept. So it's always going to be this number that's in front of my base to a power. So same with over here on the second graph. 3 times 2 to the power 0. That's going to be 3 times 1, which again is 3. So again, this number that's in front of my base to a power, we call that our a, that is our y-intercept. So our y-intercept is up. Don't want to put a, sorry, I wanted to put 3. Over here, my y-intercept is also 3. Okay. So for these graphs, just like the ones above, I'm going to have an asymptote right here on the x-axis. The equation of those asymptotes are going to be y equals 0 for both of them. Y equals 0, y equals 0. Now, these graphs we just said are going to be starting right here with this a, which is 3. So when I'm graphing these, my y-intercept is going to be 3 because that's my a. So I'm going to go up 1, 2, 3. And then I'm timesing it by 0.1. Well, 3 times 0.1 is going to be a 0.3, which is going to be way down here, less than a half. Okay, and so forth. And then when I'm going backwards, I'm really timesing by 10, timesing by 10. So this would go up to 30, but I cannot draw that high. So when I graph this, again, I'm going to have a decreasing graph because my b is 0.1. I started at a height of 3 because of the 3 in front of my base to a power. On my second graph down here, this one also has a y-intercept of 3 because that is my a. So I'm going to go up 1, 2, 3. Now what's going to happen is I'm timesing by 2, timesing by 2. So if this is up at 3, the next one's going to be twice as high, which is going to be 6. Let's just approximate it maybe to here. Now going backwards, I took, this was 6, this is 3, so I'm taking half. Half of 3 is going to be 1.5, and then I'm going to take half of that, which is going to be 0.75. Okay, just approximating. And I am going to draw my graph. This is going to be an increasing graph. There you go. So now they say when there is a different a from 1 in the equation, what happens to the graph? So up on these ones, there really wasn't an a in front. The a really is a 1. Okay, it's just my base to a power, my base to a power. And when it's my base to a power, my y-intercept is 1. But when I have an a in front of my base to a power, every time I put 0 in for this x, this whole thing right here is going to become a 1. So I'm always going to get my a. So when it says when there's a different a from in front besides 1, what happens to the graph? The y-intercept is no longer at 1. It is at a, and I'll put my a in quotes just so you know it's not a typo. A, whatever your a is. Okay, so now on the next part, I went through the first problem with the class, and then if you want to pause and try the others and then come back and check, and I'll run through them, but you want to try to do these without me. So on the next page, we are sketching them. It says use a graphing calculator. We were not using graphing calculator. We were sketching these. So what we did first was, the very first thing I did was we're going to draw out our XY axis. So I just had everyone draw out their XY axis. You can draw it by hand, but what I did was I had us come and get the line tool, okay, and hold the shift button down. And when you hold the shift button down and you drag it straight down, it's going to keep it straight. If I do it without holding it, then it's hard for me maybe to make it straight. Okay. So again, I hold the shift. I'm going to hold the shift again when I'm doing it horizontally. Okay. And then what I did next was each of these graphs is going to have an asymptote. Every one of these graphs is going to have an asymptote on the x-axis. So we drew that in. And we always write the equation. So rewrote the equation. Okay, I'm just going to come over here. Rewrote y equal 0. So then what I had us do was, so that we don't have to do this every single time over and over again, we actually cut and pasted it. So I came up here to select, came down here to the select annotations. I kind of highlighted this. Sometimes you have to do it more than once. Okay, I'm going to do it again. Now up here, you see I've got these choices. I'm going to copy and paste. And then at this point, I can just keep hitting the paste, or I can do Control V. Now, what I did next was, since I'm going to have to do this again, on the next line, I just came and selected this whole thing, all 3 of them. Copied this, pasted this, and then I didn't have to redraw that again. And I'm going to do it one more time. And then we've got these. Okay, so that's what we did first. Then what I did was I went through the first one with us. So for this first one, again, what you want to pay attention to, let me just kind of write this out. If you have y equal a times b to the power x, your a is going to be your y-intercept. Your b is what we are multiplying by. Okay. Now, when we're doing this, if our b is between 0 and 1, I'm going to just rewrite that a little bit. Okay. So if my b is between 0 and 1, it is going to be decreasing. If my b is greater than 1, it is increasing. Okay. So when I'm looking at this and I see that here, my 2 is in front of my 3 to the power x. In this case, my a is 2. And if my a is 2, let me just jot this down. If my a equals 2, that is going to be my y-intercept. So what I'm going to do is I'm going to come to this graph. I'm just going to put a dot here. I'm not going to scale this because we're just sketching, and this is how you're going to do it on the quiz. And I put the number 2 here. Put the number because I want to know where is it. My b is 3, so that means I'm timesing by 3, timesing by 3, timesing by 3. But what you want to pay attention to is that means that my b is greater than 1, so it should be increasing. So what I had us do is we're going to draw an increasing graph with a y-intercept at 2. It's going to start here. It's not going to cross that line. It's going to come. It's going to go through this. And there we go. That's our graph. We are sketching. That's what you're going to do on all of these. But again, I want to see the asymptote, the equation for the asymptote. I want a point where it's crossing the y-intercept with the number so I know where it is. And then we're going to be increasing or decreasing. Now, the last thing we're going to do is we were talking about the domain and range for, actually for these, we just graph these, okay? We're just graphing these. So if you want to pause the video, try these problems, then you can come back and kind of make sure you did them right, okay? So at this point, you can pause and try these problems. Okay, so hopefully you paused, try the problems. I'm going to run through the answers right now. But again, you want to try these so you know if you're doing them right or wrong. So in this situation, my A is 2. So that means I'm going to be starting at 2. My B is 0.4, which is decreasing, going to end up being decreasing because it's between 0 and 1. So we start high, we come down, it gets closer and closer to our asymptote. On letter C, our A is 2 again. Our B is 3/4. Now 3/4 is smaller than 1. It's between 0 and 1. So I am going to be starting at 2 for my y-intercept. This is again going to be a decreasing graph because my B is 3/4, and there you go. Okay, on the next one, let's do these in a different color just to, so on the next one, for these ones, my A in this case is 0.5. So I'm going to be starting at 0.5. Just put a point and put 0.5 or 0.5. That's my y-intercept. My B is 3. That is greater than 1. So that means that this is going to be increasing. So it's going to start low and get higher. On E, my A is 1/2, which is the same as a 0.5. I just wrote it as a fraction this time. So I'm going to start at 1/2. That is my A. My B is 0.4. So I'm timesing by 0.4, which is smaller than 1. So that is going to make this be a decreasing graph. On letter F, my A is 0.5. So that's where I'm going to be starting at 0.5 or 0.5. My B is 3/4. So I am going to be starting, this is going to be a decreasing graph. So I'm going to be starting above, going like that. On letter G. So on letter G, my A is going to be 3. So that means I'm going to be starting at 3. Okay, put a point there, put a 3 here. My B is also 3. So that means that this is going to be increasing. We're going to start here, and it's going to be an increasing graph. On H, my A is again 3. So I'm going to be starting at a height of 3. But this time my B is a 0.4. That is smaller than 1. So I'm going to be decreasing. On I, my A equals 3. So again, my y-intercept is 3. My B is 3/4, which is less than 1. So this is going to be, again, decreasing. Now here it says, how does changing the value of A change the graph? Changing the A changes the y-intercept. How does changing the B change the graph? Changing the B changes whether, I'll just say this, changes changes whether the graph is increasing or decreasing. And I'm just going to jot down here the following. If 0 less than B less than 1, so if your B is between 0 and 1, it is decreasing. If your B is greater than 1, it is increasing. Okay, so now the next page is like our homework. Okay, these ones you just did are going to be like your quiz where you're sketching. The ones on the next page, they're giving us graph. We are going to be graphing them accurately. So what we did was, again, each of these is going to have an asymptote. Each of these graphs, okay, for us in our integrated 1 class, are going to have an asymptote on the x-axis with y equals 0. Okay. And each of these graphs are going to end up having the same domain and range. And we're going to talk about that in a second. So if you want, you can copy this and paste it. Okay, so you've got that on all of them. So you want to make sure you put that on like your homework tonight. Now, let me just graph this first one with us, and then again, the class graphed the rest of them. But we did talk about domain and range real quick on these. So when we were looking at this graph, and we noticed that our A is 4, okay? So our A being 4, that meant that that's our y-intercept. So we came to 4. I'm going to get a bigger point. Okay, so we came to 4. We put that as our y-intercept. Now our B is 2. Now what that B being 2 means is that we're timesing by 2. So if this is 4 high, I times that by 2, the next one's going to be 8 high. I times that by 2, the next one's going to be 16 high. I times that by 2, the next one would be 32, but it's not going to fit. Now make sure you graph on the other side. So this is 16, 8, 4. Notice I'm taking half of 16 is 8. Half of 8 is 4. So I'm dividing by 2 or taking half. So if this is 4, half of 4 is 2. Half of 2 is 1. Half of 1 is a half, and so forth. And then we connect this graph. And that's our graph. Now, what is going to be true for all of these graphs, and you're going to have to do this on your homework tonight, is they're going to ask you for domain and range. I'm going to write this in a different color because I'm going to cut and paste this. So my domain for this graph, that's your x's, is how far to the left does the graph go, which is negative infinity, and how far to the right does the graph go, which is positive infinity. So I'm going to go open bracket, negative infinity to infinity. That's going to be my domain for every one of my exponential graphs. My range is how low and how high does this graph go. So the lowest it goes is 0, but this asymptote means it's never going to cross or touch this. So it's going to go 0 open bracket, because we don't reach it, to infinity open bracket. So open bracket 0 to infinity. And this is going to be the domain and range for every one of our graphs here in integrated 1 for exponential graphs. So I'm going to come select this. Let's see, I'm going to select this, try to select just the black. So right here, just selected the black. I'm going to copy and paste because this is going to be the same for all of them. Okay. So now you try to graph 2, 3, and 4. So pause this, try those. Pause now. Okay, so again, hopefully you've tried these problems. So in the next one, when I'm looking at this, my A is 5. So that means I am going to start at 5. So I'm going to come here to 5. I'm going to put a point at 5. Now my B is 2. So that means I'm times it by 2. So if this is 5, my next one's going to be 10. I times that by 2. So I start with my 5, times it by 2, 10, times 10 by 2, 20. Now give me a graph on the other side. So if I was timesing by 2 going backwards, I'm dividing by 2, dividing by 2. So if this is 5, 5 divided by 2 is 2.5, and so forth. And then it's going to be half that distance. So I'm just going to approximate, and approximate, and so forth. And then I'm going to connect this. And there's our graph. On number 3, okay, on number 3, my A is 4. So I'm going to be starting up at 4. Now my B is 1/2, so I'm going to be timesing by a half. So if this is 4, half of 4 is 2, half of 2 is 1, half of 1 is a half, and so forth. Okay. Now going backwards, trying to make it a little higher. Going backwards, if I'm taking half and half and half, I'm doubling going backwards. So if this is at 4, before that would have been 8. Before that would have been 16. Before that would have been 32. And here is my graph. On number 4, I am going to be starting at 2 because my A is 2. So I'm going to be starting at 2. And then I'm timing it by a half. So half of 2 is 1. Half of 1. Let me just move this asymptote down a little. I had it kind of high up. Okay. Half of 2 is 1. Half of 1's a half, and so forth. Now, don't just give me this. Continue going the other direction. So if I'm taking half this way, going back, I'm doubling. So if this is 2, in front of that would have been 4. In front of that would have been 8. In front of that would have been 16. And then there's my graph. And this is what your homework is going to be like. We did submit this, okay, for points, so make sure to submit this.